In this lecture, we are going to talk about the method of false position, or the Regula Falsi method. The method of false position, or the Regula Falsi method, is a linear interpolation method used for finding an approximation for a solution of the single variable equation f of x equals 0. If f is continuous on the closed interval from x equals a sub 1 to x equals b sub 1, and if in addition f of a sub 1 and f of b sub 1 have opposite signs, so that either f of a sub 1 is greater than 0 while f of b sub 1 is less than 0, or f of a sub 1 is less than 0 while f of b sub 1 is greater than 0, then the intermediate value theorem guarantees the existence of at least one root of the equation f of x equals 0 on the interval from a sub 1 to b sub 1. These set of inequalities combined is equivalent to the single inequality that the product of f of a sub 1 and f of b sub 1 is less than 0. To simplify the discussion, let us suppose that there is only one unique solution, which we call x equals r on the interval, and so f of r equals 0. The method of false position uses the secant line through the points on the graph of f at x equals a sub 1 and x equals b sub 1. Then we find the x-intercept of this secant line because the x-coordinate c sub 1 of this intercept is the method of false positions, or the Regula Falsi method's first estimate for x equals r. An equation of the secant line in point-slope form is given by the slope m of the secant line times x minus a sub 1 equals y minus f of a sub 1. We can use as the change in y, or the rise for the slope, the difference f of b sub 1 minus f of a sub 1. The corresponding change in x, or the run, is b sub 1 minus a sub 1. At the x-intercept, when x equals c sub 1, y equals 0. Replacing m by this formula, we get the equation 0 equals f of a sub 1 plus f of b sub 1 minus f of a sub 1 over b sub 1 minus a sub 1 times c sub 1 minus a sub 1. Solving for c sub 1, c sub 1 equals a sub 1 minus f of a sub 1 times b sub 1 minus a sub 1 divided by f of b sub 1 minus f of a sub 1. The viewer might recognize the similarity of this formula to the recursion formula for the Newton-Raphson method. To complete the first iteration, or iteration 1, we now have to find the next interval over which we continue our search for the next estimate for x equals r. To the left of c sub 1, there is the interval from a sub 1 to c sub 1. And to the right of c sub 1, we have the interval from c sub 1 to b sub 1. Just as with the bisection method, we determine where we continue our search for the next estimate by checking the sign of f of c sub 1 against the sign of either f of a sub 1 or f of b sub 1. Without loss of generality, let us use f of a sub 1. If f of a sub 1 and f of c sub 1 have opposite signs, so that the product of f of a sub 1 and f of c sub 1 is less than 0, then we keep the interval to the left of c sub 1. If f of a sub 1 and f of c sub 1 have opposite signs, then a sub 1 is the new left endpoint, which we call a sub 2. And c sub 1 is the new right endpoint, which we call b sub 2. Otherwise, the new left endpoint a sub 2 is c sub 1, and the new right endpoint b sub 2 is b sub 1. There is one little caveat, and that is we must allow for the possibility that x equals a sub 1 is the root of the equation f of x equals 0, so that f of a sub 1 equals 0. The inequality fails in this case. This results in us throwing out the actual root a sub 1 from our search. Of course, we don't want this to happen because after all, we want the root, which happens to be a sub 1. And so to avoid making this potentially catastrophic error, we modify the inequality from a strictly less than inequality to a less than or equal to inequality. And so we have the first iteration or iteration 1. We simply repeat the process for these succeeding iterations. At the nth iteration or iteration n, with the interval from x equals a sub n to x equals b sub n, c sub n equals a sub n minus f of a sub n times b sub n minus a sub n over f of b sub n minus f of a sub n. If the product of f of a sub n and f of c sub n is less than or equal to 0, then the new left endpoint a sub n plus 1 is a sub n, and the new right endpoint b sub n plus 1 is c sub n. Otherwise, the new left endpoint is c sub n, and the new right endpoint is b sub n.